Now let us see the theorem 2, converse of basic proportionality theorem. Already we have learned basic proportionality theorem, how to prove. Now you are going to learn how to prove the converse of basic proportionality theorem. Okay, so reversely you are going to take nothing but in the BPT theorem what you have considered as a given part, that part here you are going to prove. There what you have proved, that part here you are going to consider as a given part. Reversely you are going to take. So that's why we have called as converse of basic proportionality theorem. Okay, so now see the statement. If a straight line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. Okay, so in the BPT theorem, this is the given part. I put it the bracket no. So this is the given part. This part you have proved. But here this is the given part. This is the proving part. Reversely we have taken. Okay, so now see, if a straight line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. So in the BPT theorem we have seen, first you have to draw one triangle, then make the triangle name ABC. After what you have seen in the BPT theorem, you have to draw one straight line, that is DE. That line is parallel to any one side of a triangle. That means DE is parallel to BC. This is the given part in the BPT theorem. DE is parallel to BC means this straight line, this DE line, it divides any two sides, other two sides of a triangle in the equal ratio. That's the proving part in the BPT theorem. What is it? AD divided by DB is equal to AE divided by EC. Keep it in your mind. In the BPT theorem, DE is parallel to BC means this line, it divides the other two sides in the equal ratio. That means AD divided by DB is equal to AE divided by EC. But here reversely they have given, if a straight line divides any two sides of a triangle in the same ratio. That means first you have to draw one triangle and make the triangle name ABC. After draw one straight line, the name is DE. Okay, so this straight line, it divides any two sides of a triangle. This line, it divides which two side? This side and this side only. Okay, so the D point and E point only it is dividing. So this DE line, this straight line, it divides any two sides of a triangle in the equal ratio. That means AD divided by DB is equal to AE divided by EC. This is the given part in the converse of BPT theorem. Okay, so this is the given part. What do you want to prove? This straight line, it divides the sides in the equal ratio. Then you can say that straight line must be parallel to the third side. That means you need to prove DE is parallel to BC. That one only you need to prove. In the BPT, this is the given part, this is the proving part. But the converse of BPT, this is the given part, this is the proving part. Okay, so next one, construction. You are going to assume this, suppose these two lines are not parallel, but we need to prove what is it? These two lines are parallel. DE is parallel to BC only you need to prove, but we are going to assume, suppose these two lines are not parallel. DE is not parallel to BC. That only you are going to assume. If DE is not parallel to BC, then you have to draw another one line. So make it another one line. D to F, you have to draw another one line. Okay, so make the letter DF. Okay, so now you are going to consider this line and this line only you are going to consider. No need to take this line. Okay, but you need to prove these two lines are parallel only you need to prove. But now here you are constructing, if D is not, we are assuming D is not parallel to BC. That means these two lines are not parallel, we have considered. Okay, so now another one line we have make it, that is DF. Now you are going to assume these two lines are parallel. DF is parallel to BC. See, here D is not parallel to BC. After draw, DF is parallel to BC. This we have constructed. Okay, so the next one, already in the using the BPT theorem we know that these two lines are parallel. DF is parallel to BC means, then you can say this line divides other two sides in the equal ratio. These two lines are parallel. DF is parallel to BC means, what you have seen, this line divides the other two sides in the equal ratio. Then what is it? AD divided by DB is equal to AE divided by EC. Like that one we have to check. So see that proof. First put the number. After statement, each step you have to write the statement with the reason you have to write. So the first step, here what is the given part? That part you have to consider as a equation 1. So you have to write AD divided by DB is equal to AE divided by EC. That you can consider as a equation 1. So the reason is, that is the given part. Okay. So the next one, construction, what you have taken? In a triangle ABC, this is the construction. We have considered, what is it? DF is parallel to BC. Okay, so we have constructed this one. So that one you have to write. In a triangle ABC, DF is parallel to BC. This is the construction. Okay, so the next one, I know that using the BPT theorem, this line and this line is parallel. so DF is parallel to BC mean this line, DF line, it divides the other two sides in the equal ratio. Then how will you write? AD divided by DB is equal to AF divided by FC. Okay, already we have seen in the BPT theorem. So using that BPT theorem, these two lines are parallel, they have mentioned. Already we have taken this to DF is parallel to BC, we have taken. Okay, so these two lines are parallel mean you can say this line divides the other two sides in the equal ratio. Then what you can write? AD divided by DB is equal to AF, this line not, okay, AF divided by FC. These two lines only parallel we have set. Okay, so then AD divided by DB is equal to AF divided by FC. So write this one because DF is parallel to BC. Though using the Thales theorem, that means BPT theorem, you can write it divides the equal ratio. AD divided by DB is equal to AF divided by FC. So put to the equation 2. So now from equation 1, equation 2, now you can compare. Here AD divided by DB, here also AD divided by DB. So the left hand side if it is equal means the right hand side also equal only it will come. Okay, so the left hand side here it is equal. So then right hand side also equal only. So you can write the right hand side AE divided by EC is equal to AF divided by FC from equation 1 and 2. Okay, so the next step you are going to add 1 on both sides. Okay, so adding 1 on both sides. So here left hand side and then right hand side add it 1. So AE divided by EC plus 1 is equal to AF divided by FC plus 1. So after take the LCM, here LCM what it will come? EC is the LCM. So AE plus EC into 1 EC is equal to, here also take the LCM is FC. So AF plus FC into 1, that is FC. Okay, so after take the LCM you have got it this one. Now see here, instead of this numerator AE plus EC, they have splitted and they have splitted. Okay, so you have to, instead of this one you have to write in another way. So AE plus EC, now see here AE plus EC. So this part plus this part only they have given. So AE plus EC, instead of what you have taken, what you can take, see AC, AE plus EC, instead of you can take AC, that full length only you can write AE plus EC. Okay, so that AE plus EC instead of you can write AC. So you can write AE plus EC instead of AC divided by EC is equal to, the next one here also you can write AF plus FC instead of, so AF plus FC. So this small part plus this part, that means AF plus FC instead of what you can write this full length, can you write full length mean AC. So you can write AF plus FC instead of you can write AC. So now you can see this here also the left hand side the numerator AC you have, here are the right hand side numerator AC you have. So see, you can cancel it because this AC, that is a multiplication. If you transpose on this side it will become division. So AC divided by AC only it will come, you can cancel it. So no need to bring it that one, here itself we can cancel it. This is the same place means you can cancel it. Okay, so now we will get, what is it, 1 by EC is equal to 1 by FC will get. So after cross multiplication what we will get, because in between equal to you have, so you can cross multiply. So EC is equal to FC you will get. Again you can see the left hand side C you have, the right hand side also C you have. So you can cancel it or not, this C, after this C you can cancel it. Okay, because this is the multiplication. If you transpose here that will become division only, so it will cancel. So here itself we can cancel it. So now you have got it, what is it, E is equal to F. E is equal to F mean this both one is equal only they have mentioned. That meaning is what, D is equal to DF. These two lines are equal only they have mentioned, because E is equal to F only we have got it. Okay, so these two lines are equal mean already we have mentioned, what is it, DF is parallel to BC. So DF is parallel to BC we have taken, but now we have proved it, what is it, these two lines are equal we have proved it. So then DF instead of what you can write, D is parallel to BC only you have got it. That part only need to prove or not. So you can write E is equal to F mean that two lines are equal. So already we have assumed DF is parallel to BC only. So DF is equal to DE means you can write D is parallel to BC. Okay, so both lines are equal. So then what you have assumed, D is not parallel to BC only we have assumed, but we have got it, D is parallel to BC only we have got it. So you can write our assumption D is not parallel to BC is wrong. Okay, so hence you have proved D is parallel to BC. Okay, so that's the proof of this theorem. Thank you.